Hi, alright, let's look at this problem. This is examples under the subtopics of Poisson distribution, right? Probability involving Poisson distribution. So, okay, let's read the question and try to understand the problems. So, the question is given that the average number or the mean numbers of students entering the library between 9 a.m. to 9:30 a.m. means this is a 30-minute interval during the school holiday, right? During the school holiday is 10, right? Is 10 means that the number of students, right, in a 30 minutes interval means that from 9 a.m. right to 9:30 a.m. So it's actually 30 minutes interval, right? So means in this 30 minutes interval, we expected that the means of the student, right, average number of students entering the library will be 10%, right? 10 people. So for this type of case, they were giving you a time, right? The interval where if in this 30 minutes, there will be have 10 students entering the library during the school holiday. So if you have 1 hour, right, you know that if you have 1 hour, you are expected, right, the mean, or I use the word expected to have 20%, right? If 30 minutes you have 10%, means that if 60 minutes, it will be double, right? If it's 20 minutes, 20 people, right, entering the library. So this type of case, we usually we read as we know that it's a Poisson distribution, right? So which talk about numbers in the interval. So calculate the probability that 3 to 5 students will enter the library at that particular time during the school holiday, right? Calculate. What is mean by probability that 3 to 5, right? Probability that 3 to 5 means 3%, 4%, or 5%, right? So means it's 3 up to 5%, right? In between 3 up to 5. So you know that x must be an integer, right? It will be 3, can be 4, can be 5. 3 to 5. So, alright. So you have two ways of finding the answer for this. One is using the probability statistic table, or you can use formula, right? Okay, so let's look at it. If I want to use statistical table, so I need to write this to, because I want to 3, right? We have 3%, 4%, or 5. This is the meaning of 3 to 5, right? 3 to 5%. Can be 3, can be 4, can be 5. So it means that 6, 7, 8, right? So on and so far. So I just want 3 to 5. So means that I starting, if I want to read the statistical table, I have to write in this form, right? At least 3, right? At least 3. Means 3 and above, right? 3 and above, 3 and above. Minus away 6 and above, right? Because I want 5, I want 4 and 5, I don't want 6 and above. So I have to minus away probability of x greater or equal 6, right? In order to get the probability from 3 to 5. Alright, let's look at the value from the statistical table. So this is a statistical table for matriculation. So we apply. So we very easy. We apply. We finding the value of lambda. So we have to don't look at the binomial probability. Now we are move on to Poisson distribution, right? Poisson distribution. So as you go, you see that for Poisson, we just look at the mean, right? I have to define the mean. The most important, I have to define the mean. So the mean for this problem here in this 30 minutes, right? In that particular time is Poisson distributed with mean of 10%, right? 10%. So means in 30 minutes, 10%, right? So as the question saying that, in that will enter the library at that particular time, means this time, all right? 9 to 9:30 a.m. during the school holiday, right? So we know that the mean is 10%. So as we go to the table of Poisson probability, so we find the mean. The mean refer to the lambda here. This is the value of lambda. So 10, right? Start from here, 0.1. We search, all right? We search one by one. Here we have 3. So we search one by one. So 5.1 to 5. Okay, no, right? So we can see where is the value of 10 here. Here is 9, right? So on. Okay, then we can see here 10. Can you see that? The page 15. So 10, right? 10. So you look for this value 3 and 6, right? So you just look at the mean here. The mean is 10, right? So then you search for the value of 3, right? 3 and 6. So during 3, it will be 0.9972, right? 0.9972 minus away probability of at least 6. Okay, at least 6. So 6, 0.9329. 0.9329. So then you can evaluate your probability. Alright, the answer will be 0.0643. Alright, so this is the probability required by the question. Alright, okay, let's look at part B of this question. If the probability of at most m student, right, entering the lab at that time, means that the same times from 9 a.m. to 9:30 a.m. during the school holiday every day, alright, so it's 0.583. If the probability of at most m student, right, at most m student is right as at most m, so the most also m, right, either less or at most it will be m. At that time is 0.583, right? So they require to find the m student, right? The value of m here. So okay, definitely if we want to use statistical table, this will be easier, right? This will be easier. You can just write 1 minus with probability of x greater or equal m plus 1, right? Oh, why I can write this to be this, right? Okay, let's understand this concept here. Let's say if I have at most 2, for example, if I have at most 2, what I should write is, I'm going to write this to be 1 minus, because 0, 1, 2, 3, 4, 5, 6, this is all the integer value. This is a discrete random variable, so they want x less or equal to, right? They want x less or equal to. What does it mean by less x or equal to? Can be 0, can be 1, can be 2, but at most is 2, right? They don't want 3 and above, right? 3 and above. That's why usually we will write x greater or equal 3, right? We don't want 3 and above. So if this is 2, here will be 3, right? So if this is 2, here will be 3. So it means that add by 1, right? That's why we have m plus 1 here, right? M plus 1 here. Same thing also, if we have at most 4, at most 4. So it means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? It can be, the x here represent the number of students, right? The number of students, right? The number of students at that particular time, 9 to 9:30 a.m. is 10%, right? It's 10%. The mean, all right? We say that during that 30 minutes, we expected it have 10%, right? It can be less, it can be more, we don't know, right? That's why we need to calculate the probability here. So now, if they said at most 4, right? At most 4, so means that we want, can be 0, can be 1, can be 2, can be 3, can be 4. At most, paling banyak 4. So means it's for this, right? So we don't want, right? We take everything, 1 minus everything, the total probability will be 1. So we minus away the probability at least, because we want up to 4. The 5 and above we don't want. That's why we put a 5 here, right? If 4 here be 5. So it means that if 4 here be 5, means this is 4 plus 1, right? This is 2 plus 1. So that's why I will writing this, okay? Hope you understand, because you have known this knowledge. So now you have less or equal m, then we write m plus 1 here, right? So definitely, okay, later on, I try to solve this. I move this to the other side, and this go to the other side. So 1 minus with 0.583. So which we're giving you 0.417. 0.417. As you already convert, right? Convert it to become greater or equal, right? You can, using the statistical table, a statistical table giving you this type of distribution, right? The upper distribution. So, okay. So let's look at the mean, right? Let's go at the mean 10, right? The mean is 10. So you search for this value 0.417, right? Where is 0.417? Right, as you're searching, there are no value here. Okay, so never mind, you go for the next page. Next page. So under 10, right? The mean 10, right? The mean is 10. So you're finding there is a value here, 0.417, right? 0.417. So means that at least 11, right? Means that probability of at least 11 from the statistical table will be 0.417, right? So as we can know that m plus 1 is actually 11 and the m will be 10, right? The value of m will be 10. So means that the probability of at most 10 students entering the library at that time is 0.583. So the value of m here is 10, right? Hope you understand.